And now we have a presentation on Azure High Performance Computing in Cloud Overview by Mr. Sachin Nagpal, Regional Sales Leader, HPC, Microsoft Asia. Platform is all yours, Mr. Nagpal.
Hello, this is Sachin Nagpal, and in this session, I would be covering about Azure High Performance Computing and how it's going to help universities and academia research institutes to leverage the power of high performance computing to do more of innovation. Just to help you understand, HPC is high performance computing mean a lot. It is the heart of any innovation center or anything you want to innovate, whether it is from architecture to engineering, whether you want to do drug discovery, whether you want to do computational chemistry, whether you want to do crash testing, circuit designing, and in healthcare from cancer research to genomics, even the material science. The world is filled with ever expanding technologies, and everything we do, every product we build, every decision we make, grounded in our mission. And high performance computing is heart of that innovation or heart of that mission. We at Microsoft stand with everyone and who is driving this positive change for the humanity, and we really help work with a lot of institutes across the globe to make this happen. As I said, HPC is heart of that, and in next few slides, I would talk about how we can really help you to drive your students and drive your professors to more innovative using a very agile platform. Why HPC matters? High performance computing. If you look at driving innovation nearly every industry. It is solving scientific and real-time problems like fluid dynamics, finite elements analysis, weather modeling, subsurface exploration. And there are tons of another use case, where you look at HPC is touching everybody's life, when it comes to the weather modeling or weather forecast, you're dependent on looking at, some of the news channel, how the weather would be. But again, tsunami predictions, the floods, the change in nature environment, how those things are, looking at the earthquake warning. So these all requires a huge high performance compute platform to do it. And what you need or researcher or professor need is innovative, a new platform which can give them that capacity to do those computational. What you need is, and it has to be running in parallel and in scale, because when you try to do a oil exploration, you need to do a lot of combination simulation to go there. How do you really use that data to deep insights, the data-driven approach, the, driving smarter simulation, empowering intelligent decision-making, and not at least, the save time and money that deliver these results much faster in an optimized way. That's where high-performance computing, provides you a groundbreaking scientific discoveries, game-changing innovation. And that's where, a lot of our customers are utilizing these platforms. I would try to show you one example which has been led by the Duke University, and this happened recently, during the COVID time. This is a example where, ventilator have become a scarce resource as the COVID-19 pandemic spreads around the world. The Professor Randalls and her team at Duke University rushed to find a safe and easy way to effectively split a single ventilator between the two patients. They partnered with Microsoft AI for Health to run over 800,000 computers hour in just 36 hours to build a life-saving solution. Let's hear from Amanda Randalls what she's talked about, using these capabilities.
So this all started very early on in the entire pandemic. You heard in the news every day that there was a need for more ventilators. One of our colleagues wanted to create a device to help improve ventilator capacity in splitting ventilators between two patients. To do that, we needed to run hundreds of millions of simulations that in total required almost 1 million compute hours. We applied to the COVID-19 HPC Consortium, and then they paired us with Microsoft AI for Health. They pulled in experts and they figured out everything we needed for the infrastructure while letting us focus on the science. By Monday morning, we had completed 800,000 compute hours and finished the entire job within 1 week of submitting the application. We used the Azure Cycle Cloud platform because it allowed for dynamic, resilient computing. We were able to get 800,000 compute hours over a weekend. It was pretty amazing to be able to submit for FDA approval less than a week and a half after requesting the compute time. We hope that having a device like this will allow physicians to have a safer way for making these difficult decisions.
So you heard right, how the Azure HPC platform, they were able to do that job in 36 hours with, 100,000 computers hours. That's where, the flexibility and the cloud agility comes into the picture, and it really helped that. Now, always there is a question, traditionally HPC in on-premise, how it is moving to the cloud, how it would, impact us. But just to give you an idea, there are customers, there are universities, there are academia institutes, there are a lot of professors across the globe utilizing HPC on cloud. Currently, it's about 47% of workloads all in cloud. If you asked me a few years back, yes, there was challenge, but just want to highlight how we are overcome this challenge in past few years to make HPC performance on the cloud. And I just want to share with you, how Microsoft Azure HPC Platform has breakthrough. Means again, these are some of examples where we provided the first for cloud. We were the first one to leading about 20,000 cores MPI job back in 2019. We were the first one to bring 200 Gbps HDR on the cloud. If you understand how much the interconnectivity, RDMA connectivity, as well as the MPI scale work. In 2020, we were the first one to run 80,000 cores MPI jobs. That makes the first cloud 12x better than any other cloud provider. In 2020, we again did it with top 5 scale supercomputer for OpenAI, again the first one on the cloud. Again, there are many things. The latest one, earlier this year, we are providing UK Met Office as a supercomputing as a service. So, the people are now looking cloud as the supercomputer, and we have, worked with our engineering team, our customer together to give them the performance, to give them the scale which is needed. We are the only cloud service provider providing, 1.6 terabytes InfiniBand, with NVIDIA. We were the first one to launch on the day, the new next generation processor got launched from AMD. We were the first one to running them in scale. So, the customer expectations on the performance with high performance computing, we are able to deliver it. And, we continue to deliver this kind of innovation, this kind of the latest platform for our customer to take advantage. As I said, high performance computing is heart of any organization, heart of any, government organization, academia and research, where these ideas gets into the reality using these platforms. We'll talk about, what are the challenges, what are hindering, customers moving to the cloud. Again, if you look at the challenges are, the demands are sometimes spike demands. COVID-19 was a great example, and you saw Duke University. You can't have in 36 hours, that kind of scale of supercomputer. It takes, months and years to bring them to the live, on premise, but using the cloud, it is really, really helped through that. Again, the infrastructure, you buy infrastructure, you buy it for 3-4 years, but you really can't use, after 3-4 years, because the demand of innovation is keep growing every year and every day, and your legacy infrastructure can't really deliver it. The third thing comes into the picture, how the seamless, experience would be. As I shown you, you really have great platform, the innovation which is happening on the cloud. It's much more, kind of the bare metal performance you are able to give. And third, and not the last, the need capabilities to get deep inside as it, HPC and AI are converging. So there are tools available on top of, platform for you to utilize those insights and provide to the better decision making. So these are some of the challenges, and I would say rising to the challenges with Azure HPC, we provide the best optimized performance with cost control. This is what we try to look at end-to-end workflow agility. We have invested in services like Azure Cycle Cloud, which you really heard from the Duke University, how they really use it. The production class platform we talked about, the day one when we launched, the AMD launched Milan processor, we were the first one to have those platform available on Azure in a scale manner. And incorporating intelligence, the AI, the Azure machine learning services on top of that, with a lot of simulation work, all of those really helping you to rising this challenge of what you face in day in day out, or maybe your teams, your researchers, your professor face. But these are the platform, Azure HPC platform can really give them the advantage to take it forward. Always, when it comes to performance, people look at how it will be cost control, because Azure or any cloud platform will provide you infinite resources, but how you really do that, so the best would be the optimized performance with the cost control. As I talked about, Azure Cycle Cloud, we provide that as an orchestration layer, which can really help you scale when you need it. And when you don't, when your job is done, it would automatically scale down. So these are the kind of functionality we have inbuilt. We have purpose-built infrastructure. As I said, when I say purpose-built, it is totally meant to run these bigger workload, the bigger computational, the subsurface one, the computational chemistry one, the quantum espresso, the quantum computing. So we have, dedicated platform which comprises of CPU, GPUs, FPGAs, and the faster interconnect to really make this platform, for our customers to take advantage of and can provide you the best price performance. The other thing, the cloud versatility that allows you, infrastructure on demand. Whenever you need it, the moment you submit a job, it will spin up those clusters. When the job is done, it will scale down those clusters. So you're only paying for as you consume or as you use it. So this really helps you, optimize performance with cost control. Again, to show you how the scalable is, we talked about, we have now supercomputing as a service for UK Met Office. We have run these workloads on scale, as compared to what you see on premise. We have run up to 100,000 cores. The other example we have, the US Navy uses, weather prediction with 100,000 cores, using that. We have run, Leemans, if you understand, this physical simulation, Leemans is one of the benchmark here where we have run 1 billion cells model. We have a platform which provides you 45% more memory bandwidth. Again, the 80% cost reduction from a fixed size to on-premise to, compute grid to on-demand. It would vary customer to customer, but, Azure HPC really solves your complex workload. It is the right platform for you to look at, when your researcher or professors or your students trying to look at, solving some of the complex problems which they have on hand. Just to tell you, we partner with a lot of ecosystem as we build this platform. Ecosystem plays a very important role. That's where, we work with industry leader partners like Intel, AMD, NVIDIA, Siemens, Mellanox, MSC Software, Ansys, Dassault System, Altair. These are our, core partner. And Azure, this robust partner ecosystem from hardware partners through the software vendors and system integrators. Many of these software vendors work closely with Azure to ensure their application have great performance. So in my last slide, I'll try to say, you could do a lot more. Innovation is the core heart of high performance computing. Azure has the purpose-built platform, which has the most comprehensive GPU lineup. We have application scale up to 100,000 plus core. We have the fastest interconnect between this cluster. We use interconnect from Mellanox, which is now NVIDIA, running up to 200 Gbps connectivity. And again, from a storage point of view, which is again an integral part of high performance compute, there are range of, parallel file system available from Lustre to BGFS, which are there. From an orchestration point of view, we talked about Azure Cycle Cloud, how customer has used it. That's a great, tool available free of cost to our customer to take advantage of scale up and scale down. And then, not the least one, the intelligence services like Azure ML, the AI, the deep learning, all of those are scale on available. Your users or your students, professors, researchers can really take advantage of the HPC platform to deliver more research as well as the innovative ideas. Yeah, this is what I wanted to share with you. Thanks for your time and looking forward to working with some of you. Thank you. Have a great day.
Thank you, Mr. Nagpal, for a precise and impactful presentation. Now it's time to wind it up. Stay tuned for the closing remarks.